All right, calculus, welcome to whether it happens to be some e-learning notes. We're getting ahead of this one, folks, for February 19th, 2025, or just catch-up notes in general. Here it is, section 4.3, towards the end. So when I say find it all, I'm talking about intervals of increase, decrease, local min, max, intervals of concave up, down, and inflection points, the first and second derivative tests. So what we're going to do is we're going to set the derivative equal to 0. The derivative is 4x to the third minus 4x. Factor out the 4x you got in common. 4x times x squared minus 1. That's 4x equals x plus 1. X minus, or 4x times x plus 1 times x minus 1 equals 0. You have three critical numbers of 0, -1, and 1. All right, so we got some intervals here. Three critical numbers means 4 intervals. All right, it's a little bit longer here. -infinity, -1, first critical number, -1 to 0. Second critical number, 0 to 1, third critical number. And finally, 1 to infinity. All right, so test numbers chosen there. And then plug those test numbers in here. Now, technically, like, you can do this, all right, because you square it, you always get a positive. But I chose this bottom one. That's fine. A negative times a negative is a negative. Decreasing. A negative times a positive times a negative is a positive. It's increasing. Positive times a negative is a negative. It's decreasing. And a positive times a positive times a positive is a positive, and that's increasing. It's increasing on -1 to 0, union 1 infinity. It's decreasing on a -infinity to -1, union 0 to 1. All right, when it goes from decreasing to increasing, that's a possible min. When it goes from increasing to decreasing, that's a possible max. When it goes from decreasing to increasing, that's a possible min. So there's two possible mins. One of them might win out, though, okay? We want the miniest, the lowest of the mins. So here's the first possible min. I take -1 and I plug it in. I get 1 minus 2 plus 3 is 0. Oh, it's over here. All right, and then the other possible min is at 1. This time I get 1 minus 2 plus 3, and that's 2. Well, that min is smaller, so that's the actual local min. And what's the local max? Plug 0 in, and that's an obvious 3. You have a local max at 0, 3. All right, that's everything we get from the first derivative. Again, so these find it all questions hopefully make the first questions we talked about in section 4.3 easier. All right, those are the questions you might see whenever we take this this next quiz, okay? F double prime of x is 12x squared minus 4x. And that's, yeah, so look at, that's f of x. This is f of x, so take the derivative of this. All right, so move that over and divide by 12 and take the square root. That's plus or minus root 3 over 3, which is not great. It's not a great answer, all right? But it is what it is. So -infinity, negative root 3 over 3, negative root 3 over 3 to positive root 3 over 3, and root 3 over 3 to infinity. Negative root 3 over 3 is what, like a negative 0.57 something. So you could have used the -1, which was on the safe side, and used -2. Okay, so let's plug it in right here. So that's going to be, I think, 48 minus 4, positive. Plug 0 in, -4, definitely negative. Plug 2 in, it's going to be positive 44 again. So I see I did again. I said increasing, decreasing, increasing. Nope. Concave up, concave down, concave up. So it's concave up on this, union this, concave down on this. So it changes concavity twice. Okay, so there's 2 inflection points at negative root 3 over 3 and at root 3 over 3. This is an even function, so you're going to have the same y value. Okay, you're going to plug it back in the original. You have inflection points at negative root 3 over 3, comma, just plug it in, and it's going to be the same y value here. Okay. We got a few notes today. All right, we're just going to continue. I think this is it's a lot of algebra that we can just get more reps in via video. All right, so you guys can handle it. You guys are in calculus, as I'm sure you like to remind it all the time. All right, example 2, x to the third minus 12x plus 2. Again, we're gonna find it all here. So what's the derivative? It's 3x squared minus 12. Set it equal to 0. So I factored out because again I want to plug things back into like factored form here. So I didn't call it like 3 times x plus 2x minus 2. You can do that instead, because it's a pretty nice factored form to plug something in. Instead I just set this equal to 0 and got my 2 critical numbers, -2 and +2. So these are my intervals. And then what's a good test number? -3, 0, 3. So I plugged them in right, because this is always positive, so I plugged them in right here. Plug -3 and you get 5, that's positive. Plug 0 and you get -4, that's negative. Plug 3 in, you get 5, that's positive. Increasing, decreasing, increasing. Increasing on, -infinity, -2, union 2 to infinity. Decreasing on, -2 to 2. All right. So, here's what we're going to do. It goes from increasing, decreasing, so that's a local max at -2 something. And then it's decreasing, increasing at 2, so that's a local min at 2 something. I plug -2 back into the original, and I think it's 18. Plug +2 back in the original, I think it's -14. Again, I look at these. I said the max was at 18 and the min was at -14. So if you made an error up here and you say, hey, the max is at -14, the min's at 18, that you should pause and you should go back and check. It's probably an error right here. Okay, we probably have, you know, the f of x, the intervals of increase, decreasing flipped. All right, what's the second derivative? If the first derivative is 3x squared minus 12, the second derivative is simply 6x. We set 6x equal to 0, get 0. All right, so test number -1 and 1. Plug -1 in there, it's negative, concave down. Plug 1 in for x there, it's 6, positive, concave up. Concave down, concave up. Concave up on 0 to infinity, concave down on -infinity to 0. Inflection point at 0, 2, where 0 changes concavity. Plug 0 back into the original. We're always plugging, when we want to find min and maxes and inflection points, we always plug it into the original. Always back to the original. Okay. We're actually getting close to the end of this chapter, believe it or not. All right, so this is a cool Desmos graph. So we're gonna look at, we're not gonna solve it all here. In fact, we're just gonna do the first derivative test on this. I just wanted to see how this went. So the square root of x minus the 4th root of x, you should go to Desmos and type in exactly what I have here. X to the 1/2 minus x to the 1/4. Okay, find the derivative, bring down the power, 1 power less, bring down the power, 1 power less. Okay, so I added this over to the other side, and I just put those negative exponents down south, okay? So it's important, guys. Well, first, pause. Let's look here, because we're going to get an answer of 0, but take a look at this actual graph. We're talking about the square root of x, so x has to be 0 or more. X has to be 0 or more. And here, like, for the derivative, you can't get 0 or less. All right, so if I just, so here it actually is, x has got to be greater than 0. Did I say x bar? That's funny. And then here, guys, if I look at my graph, because again, we're answering questions about the graph, x has to be greater than or equal to 0, right? And if I look down here, x is not allowed to be 0. So, oh, that makes it a critical number, though. Like, I get an answer, if it makes it undefined, I'll get an answer of 0, and it's allowed in the original. But I digress. All right, so what we're going to do is we're going to cross multiply. I'm going to divide by 2, okay? So, common denominator here is 4. Okay, so I'm going to raise both sides to the 4th power. That's going to be x squared. 2 to the 4th is 16. They cancel. All right, so I'm going to move this over. 16x to the 3rd minus x squared. Not factor out 16. I'm going to factor out the x squared they have in common. 16x minus 1. Cover method. I get x squared is 0. X is 0, but, you know, it's not allowed to be 0 here, and it's got to be greater than 0, greater than or equal to 0 for the actual graph. So I'm going to, like, my interval already has to start at 0 for my graph. Okay, so it's not going to be -infinity to my first one. I set that equal to 0, and I get 16x equals 1. X is 1/16. I have one critical number that's going to be useful here. Again, I made a mistake. I said like negative infinity to 0, but no. Can't have negative numbers for f of x because I have a square root of a negative and a fourth root of a negative, which is also not good. So 0 to 16, 1 over 16, 1 over 16 to infinity. What's the test number? How about 1 over 32? If I plug 1 over 32 in here, I get a half. This is always going to be positive when I square something. If I do 1 over 32 here, I'm going to have a half minus 1, which is a negative. Or how about a positive times a negative? Anyway, it's a negative, so it's decreasing. You should look at this graph. It decreases for the tiniest part, then continues to go up. When I plug 1 in for x, I get a positive times a positive, which is a positive. So it is increasing on 1/16 to infinity, and it decreases at the start for the shortest time, 0 to 1. Over 16. So it has a local min. It has a local min at 1 over 16, and then whatever you have the square root of 1/6 over 16, which is a quarter, and the fourth root of that is a half. So actually, a quarter minus a half, it should be at negative 1 over 2. Should be. You guys should check that out. It should be negative 1 over 2. That is less gruesome than we should make it. Like that part is. All right, let's see what we got. Let's see what we got. So we're going to do the same thing here. X to the fourth e to the negative x. Look at that. Let's see what we can do. We're going to go through all the first derivative stuff. So, you could rewrite it like that and do the quotient rule, but I think you guys like the product rule better. So derivative of the first times the second plus the first times derivative of seconds. What is the derivative of e to the negative x? It's e to the negative x times the derivative of negative x is a negative 1. All right, remember these questions, because e to any x can never be 0. All right, can never be 0. And unless it's a negative e, it's always positive too, but it can never be 0. So just factor out that. That's going to leave you with 4x to the third minus x to the fourth. That is what you're going to set equal to 0. Okay? And then you factor out x to the third, leaving you with 4 minus x. Almost made a boo-boo there. You have two critical numbers of x equals 0 and x equals 4. This is also a classic question for like, hey, what are the critical numbers of this function? Very classic question here. All right, so we're talking about negative infinity to 0, 0 to 4, and 4 to infinity. Okay, so I'm going, where am I going? So the fact that this is always positive, I don't have to plug anything in here. I can forget about this. So I can just look at this part, which here is in factored form. So this is where I'm plugging in my test numbers. If I plug negative 1 here, I get a negative times a positive, which is a negative. If I plug 1 in here, I get a positive times a positive, which is a positive. If I plug 5 in here, I get a positive times a negative, which is a negative. Decreasing, increasing, decreasing. All right. Increasing on 0 to 4. And then it's decreasing on negative infinity to 0. Union 4 to infinity. So if I go from decreasing to increasing, I have a min. I have a min at 0. If I plug 0 back into the original, it's 0 times e to the 0, negative 0, or e to the 0, which is 0. And if I plug, so then I have a max at 4 something. If I plug 4 into the original, I have 4 to the 4th power, e to the negative 4th power. 4 to the 4th is 256 over e to the 4th, which sounds like a huge answer, but it's not. It's not. Again, looking at this graph, you can do that on Desmos, but it's 4.6888. All right, cool. There it is, folks. Would it be a class if we didn't have a little trig? Here it is. All right, now I had one of these in my notes. I kind of changed it. All right, so I apologize, because it was gonna be like another cosine x equals 1 or something like that. We've done too many of those. So f of x is equal to x minus 2 sine x, and now I'm looking at this interval 0 to pi. I'm looking at 0 to pi, not 2 pi. All right, so what's the derivative of x minus 2 sine x? So it's gonna be 1 minus 2 cosine. I'm going to move cosine, the negative 2 over, so now it's positive. Kind of skip that step. Now it's going to be cosine x is 1/2, cosine inverse of 1/2, 60 degrees. That's the pi thirds family. So where the unit circle is cosine of positive 1/2. It's in the pi thirds family, and cosine is positive in the first and the fourth quadrant. So pi thirds, 5 pi thirds. But I'm looking at 0 to pi, so it's only going to be pi thirds. That is my critical number here. So I'm looking at 0 to pi thirds to pi. It's a good test number. How about pi fourths? Pi over 2 is great because cosine of pi over 2 is 0. All right. And I did the work down below. So my test number of pi fourths, 1 minus 2 cosine pi fourths. Cosine of pi fourths, root 2 over 2. Those cancel. I have 1 minus root 2, which is a negative number. Negative, it's decreasing. And then test number of pi over 2. Plug pi over 2 into my derivatives. Yeah, so I'm not looking for min or max yet. I've been not looking for min or max. I think I just found it all. Well, I sort of found it all. I didn't find a min or a max, which this has just what? It has a local min. All right, anyway, plug in derivative and you get cosine pi over 2 is 0. So 1 minus 0 is 1. So it's positive. That means it's increasing. Okay, so it's... I just went straight to the second derivative. Oops. So it's decreasing on 0 to pi thirds. It's increasing on pi thirds to pi. Write that down. And I have a local min at pi thirds. Local min at pi thirds. All right, so we're going to try this. So it's going to be pi thirds minus 2 sine pi thirds. So it's going to be pi thirds minus 2 root 3 over 2. So it's going to be pi thirds minus root 3, which is like not a great answer, but that's your y value. All right, what's the second derivative? So here's my first derivative. What's the second derivative? So negative 2 times a negative sign means it's a positive sign. And if I set it equal to 0, where in the unit circle is sine 0? Well, both at 0 and pi, but that's the beginning and end of my bound. So what happens here, folks? 0 to pi, it's just that is in fact the interval. Those are the two critical numbers, but they are the same as my interval. So it's just going to be 0 to pi. What's the test number? You can look this, if you looked at this graph, it's pi over 2. So all this is to say it's positive, so the graph is always concave up. That means the curve is up above the tangent line. We can see that on a graph. We'll look at it when we meet each other again in person here. So there's no inflection point. Not bad, guys. We did the full question with trig. Pretty good. I don't know if I've done that in a while with trig. So look at you. All right. So yes, this is from SIU finals. These are gonna be worth some more points here if you have to do this for e-learning. So if e-learning, you're going to put these on a separate sheet of paper, and these are going to worth a few points. You just attach them to the other questions you had from Tuesday, if you're learning. If not, these are still good examples. So I have some questions here that were from SIU finals. SIU finals. All right. So f of x is 3x minus 1 minus cosine x. I have a question like this in my notes. We haven't talked about it yet. Show that it has exactly one solution. What? How in the world do we do that? How in the world? They gave you a tremendous hint. Use the intermediate value. This is what they wrote down. Use the intermediate value theorem to show that there's a solution in the interval 0 to pi. Slam dunk, folks. Let's do that first. You know the intermediate value theorem. Plug the lower bound, f of 0. What's f of 0? Be careful here. It's negative 2. What's f of pi? You have 3 pi minus 1 minus cosine pi. The negative ones cancel and you're left with 3 pi. That's definitely bigger than 0, so it crosses 0. That means if it crosses 0, it means there's a solution between 0 and pi. Awesome. So there is a solution there. How in the world would you prove it's exactly one real solution? Well, we know that when we set the derivative equal to 0, we can figure out when the graph turns. Okay, so let's keep that in mind. So that's why we're going to take f prime of x and we're going to set it equal to 0. So it's going to be 3 minus, because there's a minus sign on the outside, it's minus cosine. What's the, again, you can because you'll think about this later, the antiderivative of negative cosine. But the derivative of negative cosine is positive sine, or you can put the negative on the outside and take the derivative of cosine, which is negative sine. That's what I did. Well, you're left with 3 plus sine x, so that is the derivative. So f prime of x is 3 plus sine x. That is a fact, and that's going to be interesting here, because if I try to solve for x, sine x is equal to negative 3. Guys, we're in the unit circle is sine x and negative 3. It's impossible. The domain there is negative 1 to 1, all right? So if you do sine inverse of negative 3, it's going to have a domain here. Going to have a domain here. So that can never happen. That means there's no critical numbers. That means f prime of x is never 0. So it never turns. It never goes from increasing to decreasing, from increasing to decreasing, or from decreasing to increasing. So if it never turns, and I can say what the derivative is always, all right? So f prime of x is 3 plus sine x, and that's always going to be positive, because the smallest value you'll get for sine x is a negative 1. So it's always going to be, you know, the derivative is always going to be 2 or more. So derivative is always positive. That means this graph is always increasing. It crosses it. So if it's always increasing, it can only cross the x-axis one time. It crosses the x-axis and it continues to go up forever. So that's what we're getting at. You saw where the solution, it crossed the x-axis between 0 and pi, and because the derivative is always positive, it's never coming back down again. So it can never cross the x-axis. All right, and then this is the last one here. All right, your videos are sometimes the longest because you guys are my favorites here. Y is equal to x over x squared plus 1. Find the values, and locations of the absolute mins and max. All right, so another good question here from an SAE final. So where's the derivative of 0? So this would be a pretty okay question for a quiz or an exam. I'm just asking for first derivative stuff. All right. So low d high minus high d low all over the square of what's below. There it is. The denominator can never be 0. It's x squared plus 1. So we're not going to worry. Nor could be 0 no matter what. So we're just going to look up top. We're going to simplify up top. There we go. So we're going to set 0 equal to 1 minus x squared. So x squared is equal to 1. X is plus or minus 1. Those are my two critical numbers. So there are no asymptotes here because, again, nothing will make that denominator 0. It's going to be a plus or minus I. So two critical numbers are negative 1 to 1, negative infinity, negative 1, negative 1 to 1, 1 to infinity. Test numbers of negative 2, 0, and 1. So the denominator is never 0, and it's always going to be positive, right? Because you're going to square a number, add 1 to it, and square it. It's always going to be positive. So I'm going to take negative 2, plug it in there. 1 minus 4, not minus a negative 4, negative. Plug 0 in there, just 1. And then plug 2 in there. 1 minus 4 is negative. So decreasing, increasing, decreasing. Decreasing, increasing, decreasing. Anyway, decreasing, increasing means you have a min. That's what they were after. All right, we don't have to, that's why I didn't state intervals of increase or decreasing. So you have a potential min at negative 1 something, you have a potential max at 1 something. So plug negative 1 into the original, and you're going the original. So it's going to be x over x squared plus 1, it's negative 1/2. Plug 1 into the original, it's going to be 1 over 1 squared plus 1, 1/2. There's your min and your max. All right, so those two questions, if it's an e-learning day, you're gonna attach those to your other two, three, however many you had the other day, and turn those in when I see you. This is Yak Math Videos, signing out.